Yeah, let's go to this.
Unfortunately, we have two screens right now, so I'm not sure. One viewer is live, but that one isn't.
Is he broadcasting?
Yes, we are. We are broadcasting.
Is he broadcasting?
So, the problem is we have two screens, and one of them is with Tanmai and his presentation. The other one is the one that is live. So, anyone knows how to get these both together?
Well, aren't we on a little window of the bottom one?
Yes, but I believe this is the live one.
Oh.
So maybe I just turn the camera around afterwards. So I mean, I've got to be this way. So so welcome, good evening. You know, this is Santa Cruz JavaScript. We have a great talk about GraphQL from one of the creators of the open source engine for GraphQL. And so for this kind of, you know, sorry, you know, we still trying to mention this. It's a premiere. It's a premiere of getting this live on air as well as, you know, having the audience enjoy a remote talk through Hangout. It was called, it's now called by Google Hangout on Air. So now we have two screens on and I don't know what it means, but I believe that the top one where you can see me is the one that is actually live, and the other one isn't. So what I got to do is just, you know, without doing too much technical things, I just turn the camera around, and then everybody can actually watch the what's going to show on the screen itself. So yeah, welcome very much. And so yeah, number one, thanks to our sponsor at Lookers. So which you enjoy pizza, you enjoy beers. This is a great conference room, a great event. We can do, you know, hopefully as often as we can. Thank you. I'll let you talk a little bit about Lookers. And then without further ado, we go into our guest speakers. Thank you.
Hello, everyone. I'm Joseph. Just going to give a really quick overview of Looker. It's a data platform that connects directly to your database, so you can pretty much look at all the things. We're always hiring, so if you guys, not just engineering, but across marketing, customer success, finance, accounting, pretty much literally hiring all the time. So if you're interested, take a look and reference the JavaScript meetup in Santa Cruz, and we're happy to have you on board. If you have any questions about Looker as a data platform, let me know. Happy to answer any questions.
All right, so now.
Cool. So I shall get started. Hello, everybody. Thank you for having me. I'm dialing in from India. I spent half my time in India, half my time in San Francisco. So I'm on the leg of the journey where I'm enjoying the slightly warmer weather in Bangalore. It's pleasant here throughout the year as opposed to being windy and cold in San Francisco. Cool. So I think Yusuf, what you've done with the camera now allows me to see my face. It's a slightly surreal experience.
Yeah, it's probably gonna really destroy.
Okay. So this is a little awkward. Do you think
Maybe
yeah,
maybe that wasn't a great. Maybe that was the wrong screen actually. No, I'm sorry. I think it is the right screen. So we want to have people actually watch you to do the presentation.
Okay. So maybe just before we begin, could you just turn the camera to the audience and I could just ask a quick question, and then I go to the slide. So before I start, how many of you have already heard of GraphQL? Okay, and how many of you use GraphQL already? Okay, awesome. So it's not for you guys, unfortunately. But we're going to make this a little bit of an introduction, just talking about GraphQL and mostly about how I kind of dropped GraphQL back in the day. And hopefully that journey might be useful for other people as well as they kind of hear about GraphQL. So yeah, so I think you can do the camera trick now. I'm going to share my screen so I won't have to look at myself.
There you go.
All right, can you folks see?
Yes.
Cool, awesome. So I am one of the founders and creators of Hasura.io. We are an open source technology company. We started just about a year ago, and we launched our open source project just about a few months ago, where we give you real-time GraphQL APIs on postgres in a way that you can kind of connect to your apps. So kind of like the Firebase experience, but with GraphQL and on your own database. In my past life, before I did this project and before we kind of built a startup around it, I did my bachelor's and master's in computer science. I did machine learning actually, and then I kind of very quickly ran away from that and went into Kubernetes and Docker, did a little bit of consulting there for different companies, large, super large, like Fortune 3 banks and smaller companies as well. I am also very passionate about teaching computer science stuff, and I was one of the instructors of a MOOC called Introduction to Modern Application Development, imad.tech, which became one of the largest MOOCs in India. It was mostly geared towards Indian university students, and then after that, I kind of started working at Hasura. So what I'm trying to do is maybe perhaps like peel back the GraphQL onion layers and hopefully share with you my aha moment with GraphQL APIs. I kind of went through a transition where a year and a half ago when I looked at GraphQL, I was like, what's the big deal? And then when I kind of looked at it again, just about a year ago, I was like, this makes a lot of sense. And hopefully this kind of journey will help you understand or will give you one perspective on how it makes sense to me. So if you look at a traditional API call that you would do REST, let's say, for example, you were building an app like a web or a mobile app, and you had an API call to fetch, you wanted to render a profile page. And for this profile page, you wanted to fetch user information. So you would make a get API call, and you'd say /API/user1 ID equal to 1. Right, so you send a query parameter saying ID equal to 1. You make a GET request and you get some JSON response that contains the ID and the name. But now you realize that on the profile page, you also need to show the address information of this user. And so you make another API call and you say, hey, can I have the address? User ID equal to 1. And then you get the address info. And then you show that on your web application or mobile application, right? And this is a little bit yuck because you have to make 2 API calls. And you can imagine that it only gets worse with more API calls, right? So you might have like different sections of the UI that independently make API calls and then kind of load differently on the screen. And you don't want to do that. You might try to batch these API calls together. Basically, this is yuck. This is not fun. So what we do then typically, once we have made these 2 API calls, is that we kind of go to our API developer, kind of have this water cooler conversation. Hopefully, you have a nice relationship with your API developer, so that you can ask for the stable and you say, hey, could you give me 1 API call, right? I don't want to have 2 API calls. Could you give me just 1 API that I can make a call to and just fetch all of that data in one shot? And the API developer typically is not going to be happy about this because they're just like, listen, I have like real work to do. Like if you want to just get 2 pieces of data and then join them together, that's not a big deal. Why don't you just do it on the client side? And then you can explain to the developer, API developer, because occasionally they're not very super empathetic. And so you kind of have to explain to them that, hey, this is on a network call and we have users, everywhere in the world. And it takes time to there's this network latency, right, with 2 API calls, and the user experience is terrible, and do a lot of work. So, just give me 1 API call. So then the API developer kind of says, okay, cool, I'll give you this 1 API. And this is great, except when you realize that on your desktop web app, you were okay showing all of the information that you got from the API. But now on your mobile app, you want to actually show a subset of that information. So, for example, you want to show the user information, but you don't, and you want to show the address information, but you only want to show a part of the address information. And imagine that these are like hundreds of attributes instead of just being 2 attributes, right? So now you want to show lesser data on your mobile app and more data on your desktop app. And now this is complicated all over again because you're actually fetching too much data. So maybe if this is a large object, you're fetching like a few KB extra, or maybe 100 KB extra just for your mobile, which you don't want to do again because it's expensive on the network. So then you go back to your API developer and you say, hey, could you add this query parameter that would let me, tell you which columns or which fields I want to select from the model? And then that would just be easier. So then you say, okay, let's add this like fields attribute or fields parameter to the get API call. And I'll give you a comma separated list of the attributes that I want. So I want ID, I want name, and I want address dot, there's a typo there, it should be address dot street, or address dot city, whatever. And then you just get that data, right? So, so this is kind of like, we've gone through the evolution of like, oh, okay, we made 1 API call to fetch all of our information, but then we had to parameterize it to kind of say, no, we just need a subset of that information, right? Not all of it. And this is all of this process is young. And so what the nice folks at Facebook did was they said, okay, cool. What if we just think about this from scratch and we say, let's do 1 API endpoint. Let's never have multiple API endpoints. And so we call that endpoint typically /GraphQL endpoint. And let's post a parameter to it, which will kind of help us select exactly what data we want. And you can see that in the post request, the payload that we'll send it some kind of like a, it looks like a JSON-ish kind of object. And you're saying query, curly bracket open, user, curly bracket, ID name, right? And so you say brace, and so you have this braces, you have the braces from JSON, but as if you don't have the values and you only have the keys. And that kind of specifies the shape of the object that you want. And that string, this string, specifies what data you want, and also allows you to specify parameters. So you say ID equals 1, right? And then you get exactly the information that you requested for. And that language that you see on the left, that language, or the structure of that language is called GraphQL. And you can see that you can prevent, you can fetch exactly the amount of data that you want by fetching the user and the address. So you can kind of traverse a particular object and its attributes and related objects. And you can also select exactly the columns that you want or the attributes that you want or the fields that you want so that you're fetching only the data that you want, right? There is prior art to this. Almost everybody has some variation of doing GraphQL, but not in a systematic way. Netflix had something called Falcor that came out a few years ago. There's the OData spec, which also helps you achieve something similar. Lots of people have their own DSLs, where they kind of have their own, particular way of sending parameters where they specify what columns they want. But this, for the first time, was something that looked really elegant and said, you know what, this looks really nice. Like, I feel like using this API now to fetch the information that I want. There are 2 key insights to GraphQL, or to making your queries with GraphQL like this. The first insight is that your data models are graph-like, right? Your API models, not your data models. This has nothing to do with your database. GraphQL has nothing to do with your database. It is at the API layer. So if you think about like SOAP changing to REST and REST changing to GraphQL, it's at the same layer. And now if you have API models and your API models are typically graph-like in the sense that they are related to each other, right? So you have a user, the user has an address, the user might have a bunch of orders. If there's an e-commerce site, the order itself obviously references a product. The product itself references a brand, which might have more information, right? So your API model is typically a graph-like structure. So you have some root nodes in your graph, and then each node has a bunch of nodes that's related to. So that's one insight behind the structure of GraphQL. The other insight is that you control the data that you want, right? So out of this API graph, right, I only want the user's name and the addresses, the street in the address of the user, right? So you control the data that you want, and GraphQL is optimized for you having that control on the client. If you look at the structure of the GraphQL query, this is what a GraphQL query looks like. So you say query, you say user, and then you have a way of parameterizing it. So you say ID :1, and then you say ID name, address, and the address has a string, right? So the stuff in blue is a part of the syntax of GraphQL itself. The stuff in black, that is user ID name, address, string, that's a part of your, that's coming from your particular API, the GraphQL API that you set up on your backend, right? So if you have REST backend, you had a REST backend, and now you have a GraphQL backend, or maybe in both. On the GraphQL backend, stuff that is the stuff that is specific to your API will typically be the stuff in black. So and the blue stuff is obviously a part of the GraphQL syntax itself. And the structure of this query that we're taking a look at, the language as such is what is called GraphQL. So so that's kind of what a GraphQL query looks like. Let's look at like how you actually send this query to the backend, right? So I have this query, and now what are the mechanics of actually sending this query to the backend? Like how does it, what's happening underneath? So underneath what's happening is, and we can kind of look at it clockwise starting from the bottom. So you have the HTTP client, and the HTTP client makes a request that you see on the left to the HTTP server, which is now serving a GraphQL API instead of a REST endpoint or a bunch of REST endpoints, which returns an HTTP response. The HTTP request that we actually send to the server is as usual a post request to a GraphQL endpoint. And the content type is actually, and this is a common standard. The content type is JSON, but if you look at the JSON, you're sending an object that has a key called query, and the value is actually the query string that you have, right? So the hard work on the client now is to construct that query string, right? This string needs to have a particular language, but if we could somehow make this string, then we can send it, inside a JSON object. And now it's the job of the GraphQL API of the server to kind of extract that string, parse out the string, figure out, this is what the client's requesting for. The client wants the user, the client wants the user where the ID is 1, and these two attributes, ID and name. And then the server sends out a response, again in a structured way, where there's always a data key, and the data key kind of reflects the same shape of JSON that you had originally asked for, right? So that's kind of what's happening underneath. And now what we need to do is think about, how are we actually going to construct that string from our client? That's kind of what the problem is now reduced to, assuming that we have a nice language to use GraphQL with. So if you think about sending parameters to your API call with a typical get endpoint, you might have had a query parameter that said /API/user ID = 1, right? So ID was the query param, 1 is the param. But you never actually concatenate the string together. You would probably have some kind of JavaScript, like this is jQuery-ish JavaScript on the client, where you kind of get the current user ID, and then you make a get call, and you kind of set ID = current user ID, and the client concatenates the string for you, constructs the right HTTP URL for you, right? But programmatically, on the client, you would never concatenate strings, right? You would never actually create that /API/user question mark, and then do a plus, and then ID plus equals plus current user ID dot toString, right? You wouldn't do that. Any ideas on why you wouldn't do that? Any suggestions? And I know I'm kind of talking to myself here, but I can hear you guys. So, so the reason why you wouldn't do this is because one of the biggest reasons why I wouldn't do this, apart from the fact that it doesn't look nice, is that you might run into things like URL encoding errors, right? You wouldn't want to manually worry about the fact that the parameter that you're sending has spaces, has quotes, has slashes or question marks or ampersands. You don't want to worry about any of that. You just want to send it the variable that you have on your client, and it should work. So you would never do the string kind of templating or the concatenation directly. If you think about this with GraphQL, the query argument that we want to send, the structure is that whenever we want to send an argument and not the name of the field, we attach it to a field with these parentheses, right? So we say, here's query, here's user. We're querying for user. And the argument that we're giving to the user node in our graph is that ID should be 1, right? And these, again, arguments can be defined by you or by the server, saying that these are the arguments that we accept. So that's what we want to do. Now, if you think of the whole thing as a string, you'd have to do the kind of ugly work of building that string together. So if you think about that programmatically, what you would do is you would say, I have a current user ID, and then you created this query string, which is the backticks actually represent a string there. And then what you would do is substitute that variable there. You would do string templating, which is horrible, right? Which you should never do. And then you substitute this. You do the string templating business here, and after you do the string templating, you make an API call, with your HTTP client, and you say, I'm going to make a post request to the GraphQL endpoint. And here's the object, here's the JSON object. My JSON object contains a query, which is actually a string, right? This is horrible, and string templating like this is not fun. Remember that this is after ES6 and stuff where we had backticks, but if you remember good old JavaScript, we never even had the ability to kind of do string templating, right? We would actually have to use like plus operations to concatenate things, or maybe like a array that you would have a dot concat on or something. But essentially, this is fairly yuck or disgusting. And so, what again the folks at GraphQL, they kind of thankfully thought about this, and they said, what we do is we let you send a GraphQL query and a variables object. So your GraphQL query string can contain this thing, can contain like this $user ID, which isn't an actual variable. And what we can do in your variable is that you can kind of send a separate object in your post request. If you look at the bottom here, right? You can send the variables object as a separate JSON that contains user ID and the variable that you want. And then you can send the server the query and the variables separately, right? So although the query is still a string because we don't have native support for this new GraphQL language, right? We have support for JavaScript objects, and then you have the JSON utility to create JSON strings. But you can't really manipulate a GraphQL string, right? It's ultimately a string on the client. So you get to still create that string, and you have this $user ID here. And that's the variables object that you actually post. So you're sending now query and variables. And that's how parameters look with GraphQL. So, and this kind of allows you to now start separating out your code a little more neatly, right? So, for example, on the left, I have the query object, which is actually a string, where I'm not doing any string templating. And this can actually be in a separate file, in a separate module. And then where I'm actually using the query in my HTTP client, I can actually create a variables object, and then I can send an HTTP request that references the variable objects. Typically, you wouldn't even do this because you have GraphQL clients that would make it easy for you to not actually do a a post request family. You would just do a query, and you just say $query or $query, and you have different kinds of GraphQL clients to help you make that query and abstract over the post request. But the concept of having a string and a variables object, and then posting the string and the variables object, is kind of what a GraphQL server should do. The GraphQL server should accept both these things. So the next thing we're going to touch upon is that we just looked at reading data, so we looked at querying data, but you can also write data. Writing data with GraphQL or doing actions that cause mutations on the backend, or that could cause mutations or side effects on the backend. GraphQL doesn't particularly need for doing this, but it is what it is, I guess. So this is what in the REST world you typically did. You had a post endpoint and you said, hey, I want to create a to-do, on a to-do app. So you had a /API/to-do, and then you sent it a JSON string that encoded this object, which was to-do GraphQL. And the response that you got from the server was, cool, we've created this, and the ID for this to-do that we've created is 987. And here you go. If you want to use this ID, use it. If you don't want to use it, if you don't want to use this ID, I don't care. I'm going to send it to you anyway. And that's typically what the relationship between a client and a server looks like. The REST spec says that you can use post, put, delete, and patch. Kudos to you, and much hard if you actually use different REST methods. Mostly you would just end up overloading post and doing everything on post, right? But a few rare people in the world who actually use post, put, delete, patch. Nobody uses put and patch, but I think, yeah, maybe like some kubernetes API server does. But the typical backend that your developer builds for you is probably just going to have post. What this looks like in GraphQL is that your API request, you still post to a GraphQL endpoint. But instead of posting a query, what we're doing is we're posting something called a mutation. And if you think about it, it looks very similar. We're posting a mutation called add to do. And in the braces we have, we're requesting for the field that we want as a returned value. So we want the ID. We could ask for more data in the return value as well. It's up to us to ask for what data we want when the mutation happens. In the mutation, you notice that we're sending an argument. And this argument is the actual to-do object. The cool thing though is that because we now know about query variables, we don't actually have to provide the to-do object inside that string there, which would just be a nightmare of string templating. And instead of doing that, what we do is we create a GraphQL query variable, and we send that variable, which is the new to-do object, separately. So you're sending the query string, and you're sending the query variable, and the GraphQL server kind of responds to you. Right. So whether it's an update or a delete or an insert, whatever it is, we call it a GraphQL mutation. And the name of the GraphQL mutation is indicative of the action that you're doing. So if you had a mutation that said add to do, you had a mutation called delete to do, or you have a mutation called update to do. Yeah. Okay. The other cool thing that GraphQL has is that it lets you set up a real-time contract, quote unquote, between your client and your server. So let's say, for example, we were building an order app, and on the order app we had, we have like a backend on our backend somewhere, some data model that we have is an order which is actually going through a bunch of asynchronous changes. The order ID has a payment, and the payment gets marked to true when the payment gets processed. Which could happen immediately, which might happen after some time, which might happen once the bank APIs tell you that the payment is done. And then you have a dispatched column that kind of tells you whether the order has been dispatched or not. And this also might be asynchronous, not just because of the way the code is written, but because in real life that process might be asynchronous. Now on your UI, what you want to show ideally is you want to show, and that's the UI on the right hand side. What you want to show is that you want to show this kind of screen that says, hey, here's your order number 57, and the payment is pending, but now it got done. And once the payment is done, we're waiting for delivery to happen, and cool, we've started the delivery process, right? So you want this kind of real-time API for your client. If you look at the different ways of doing this, one of the ways of doing this is polling, which you can get away with for a lot of use cases. But again, it's a little bit young because just the idea of it is not fun. Like we didn't do years of software engineering, years of cutting edge computer science to kind of get this right to polling. This is horrible. It just makes you feel bad. Although in practice it might not actually be too bad. It's worse on a mobile client because creating a HTTP connection, making that network call and getting that is expensive and slow, not just on the network but for your battery as well. And so it's kind of bad technically also, but it's also just aesthetically very inelegant. The other option is to do WebSockets and to have your server do send out events over WebSockets and for your client to accept data over WebSockets. But this is a nightmare, and this has always been a nightmare. Although WebSockets have been around for 10 years, WebSockets has been a part of the HTTP2 spec. The work around WebSockets and just being able to use WebSockets is terrible. I recently found out that when you make a WebSockets call from the browser and you kind of use the browser API to send out a WebSocket event, you can't send custom HTTP headers. So I can't send the authorization header or any custom headers. The only header that you can send is authentication. It's like a basic authentication HTTP header and the URL. That's it. That's what you can send. And I don't even know why this is the case. There should be no technical reason behind why browsers don't support this. Because if you make a WebSocket call from an Android app or from a terminal client, you'll be able to send whatever HTTP headers you want. But to kind of summarize, WebSockets are a nightmare to deal with on the client. So with GraphQL, we kind of alleviate the problem on the client, but your backend developer will still have to go through the process of maintaining a WebSocket server. And so if you were using raw WebSockets, it would be a bit of a nightmare. What you get to do with GraphQL is you get to say we had queries, we had mutations. We can now create something called a subscription. And the subscription again has the same idea where we're kind of requesting for the shape of the event or the shape of the object that we want to listen to. And the response kind of contains just that data. So if you're subscribing to this order, if there is a new order event or something changes about this order, so it depends on whether you have events or whether you have live queries. I prefer live queries over events because they're easier on the client. And so if you have a live query and if the order object changes, you kind of get the new result of that particular order object. So you say, hey, page is true, dispatch is false, and consume this. And when you're dealing with the GraphQL client, you don't actually have to deal with the underlying WebSockets. The GraphQL client, because this is standardized across every GraphQL client and every GraphQL server is going to do this, the community has built out various GraphQL clients that wraps over the WebSockets and kind of gives you this interface of saying, just give me the subscription query string and we'll deal with the response. And this works out, and this is nice for us on the client side when we're building our app. Good luck to the API developers, but I mean, that's fine. So that's kind of queries, mutations, and subscriptions, right? And one of the big things that I kind of hope, I'm not sure if it came out too well, was that the aesthetics of using GraphQL is fairly high because the query string is very intuitive. You don't have to actually learn GraphQL. It's fairly obvious from the moment that you start with it, because it always represents the data that you want. But in my mind, when I zoom out a little bit, the feature that the thing that GraphQL had that absolutely killed it, and the reason why everybody's talking about GraphQL today and not say Falcor or not OData or not things that have tried to solve this problem in different ways, is when it comes to sharing or documenting APIs. And this is why you will hear people saying that GraphQL is a type system, right? This is one of the effects of GraphQL being a type system. So let's look at the process of a documentation of the API, of a API documentation process before we had GraphQL. So your API developer built the API, and then your API developer would write documentation for this API. The red box denotes that this doesn't happen often. And so the API developer writes documentation, not. And then depending on the mode of the API developer, they give you a Google Sheet where they have the URL, the endpoints, and maybe some sample input and output mention. If they're being a little more systematic, they might actually share a postman collection with you, or some kind of API tool connection with you. And if you're being like hardcore and you have a lot of free time, and you're like, okay, cool, let me just write out a Swagger spec for my API, or set up some kind of auto generation so that whenever I'm writing my API, the Swagger spec gets automatically generated, and all kinds of cool things. Except that like a lot of people don't actually end up getting around to this. It's painful, irritating work, right? I wouldn't want to do this if I'm an API developer. Now you on the client side, read this documentation, not right, because it's spread over everywhere. You're not probably reading the documentation in detail. But in any case, you kind of read pieces of the documentation and you start integrating the API into your app. And then once you start integrating the APIs in your app, you realize that the docs are either missing, or they're out of date, or they're just wrong. Because the API developers have like updated their API, but they haven't updated the documentation. Like types have changed or new fields have gotten added, and you have no idea. Or maybe they've changed string to integer or integer to string, because hey, we're all using dynamically typed languages, or JavaScript, and so nothing works, right? So and it leads to a lot of frustration, and it leads to a lot of communication between you as a front end developer and the back end developer to just use this API back. The experience with GraphQL, and I'll show you how and why this is. The API developer builds the GraphQL API, and you integrate the GraphQL API. There is almost no documentation process for both parties, because the tooling around GraphQL kind of takes care of this. And I'll describe how and why this happens, right? When we said that our GraphQL, that our API model was a graph, we look, how do you represent that graph, right? So what is the API actually doing? What is the server actually doing? How does the server represent that everything is in this graph-like format? And the server does that by actually creating a GraphQL schema. And the GraphQL schema is a definition of types that have relationships to each other. So for example, I define a type called user, which has an ID, which is an integer, name, which is a string, and an address, which is a reference to the address type. And the address type has a street, city, ID. So any of you who are familiar with algebraic data types or ADTs from functional programming languages, or structs from C-like languages, right, where you create your own types, GraphQL is kind of reminiscent of that type system, right? So that's kind of what the definition of a GraphQL schema looks like when you say that these are the various types in my API, and this is how they relate to each other. But this is something that the server kind of has. When the API developer is building their GraphQL API, the process of writing code involves the process of either manually writing these GraphQL types or generating these GraphQL types, right? So the process is synchronous for the API developer. It's not that I'm maintaining this documentation of what the type is later on, after like post hoc, after writing the API. The process of writing the API is the process of building the schema. But this is especially awesome because you can actually make a GraphQL query to fetch the type of a particular object, right? So let's kind of maybe look at that in action a little bit. So I have a GraphQL endpoint for a to-do app, right? And what I can do is I can make queries to, so this is the GraphQL endpoint, and I'm making a post request. These are the headers that I'm sending, right? And this tool is GraphQL, and the story behind GraphQL apparently is that the Facebook folks built GraphQL. The first time they took GraphQL to a few of their developers, the developers said, we are not dealing with this new language. We hate this. Remove GraphQL, give us JSON, and query that again. So the second time when they went to their developers, they kind of built GraphQL, and GraphQL had this, what I'm going to show you now. So I do a query, and then I open up a brace to kind of write out my GraphQL string. And I do a control space, and I get an autocomplete that tells me what objects I have. So I say, oh, okay, cool, I want to lose. And I open up a brace again, and I control space to see what fields I have. So I have an ID, and I have, okay, cool, I want a text. And I also maybe want the information about who the user is who's made this to do. So let's see if they have a user field. So we have a user field, and we have a username, right? And now I make this query. Right, what I can do is, let's say I misspell this on the API, so I have this, and if I try to make, let me, if I do something stupid like this, GraphQL will typically warn me and tell me, hey, this something's going wrong. You don't have this column. This field or attribute doesn't exist. And that way, whenever you're kind of whenever you're writing out your GraphQL query, you're being safe while you're experimenting, while you're trying out your GraphQL query itself, right? So what's happening, and what you can imagine is happening underneath, that GraphQL as a tool is a web kind of like a client, right? And what this is doing the same thing that we talked about. It's taking the GraphQL string, posting it to the GraphQL server, and getting that response. But what we're also doing is, and what GraphQL is also doing is that before it loaded GraphQL, like whenever I refresh this page, what GraphQL did was it made a query to the server and it fetched the entire schema. And if you go to the docs section, it will tell you what queries you have, right? So I can query for a to-do. And so what is a to-do object? A to-do object is all of these things. And it has a reference to a user object. And so what is the user object? User object is all of these things, right? And every user has a to-do as well. So, and so you have, and this little panel that you see on the right-hand side was generated automatically by GraphQL by looking at the GraphQL server schema. And the reason why this could happen was because the GraphQL server, by design, serves the introspection API, which allows it to serve the API models that it has. So I can actually take this query here. Let me go back to the street here and look at it. So this is a GraphQL query that I can make, where I can actually fetch the type. For the to-dos type, I can actually fetch the name and the different fields that are available inside this to-do type, right? So I can make a query to the GraphQL server to introspect and say, tell me what types you have, and tell me what their data types are, right? And this ability of the GraphQL API server to do this is the most killer feature on the planet. Because what's happening now is that the community is going crazy, and we're building all kinds of tools to exploit this feature. So if you have an ID, on your ID you'll have a plugin that when you type out your GraphQL query string, even though it's a string, you'll get validation for that string as you type your query, because your plugin is making a request to the GraphQL backend to actually validate whether, hey, do these columns exist? Is this matched or not? If you're using a typed language on the front end, like TypeScript or Java for Android or Swift for iOS, you'll actually have code gen, where if you write out your kind of GraphQL query, your plugin will do a code gen for you and generate the corresponding Java class or the Swift class that will generate the actual object for you. And this will again be typed, right? So if the type changes on the GraphQL backend, which it shouldn't change, you will immediately see it being reflected on your front end as well when you do your code gen, or you'll see a compile line error saying that, hey, this GraphQL field doesn't really exist. So that in my mind is like the most killer feature that GraphQL enforce servers to have, right? It's not just about that GraphQL query language, but it's also about the ability that every server must serve an introspection API that allows you to query the type system that a GraphQL server has. So that's kind of it on kind of giving you an overview of blocking GraphQL, I guess. And before I end, maybe I just talk a little bit about our open source project. Do head to hasura.io and kind of give it a spin. It should be super easy to try out on Heroku or DigitalOcean or Docker, whatever your choice of weapon is. Heroku should be the easiest to try out. And what we essentially do is that as soon as you deploy to Heroku, as soon, and I have I think a mock deployment here, what you can do is you'll see a bunch of tables, or you can create your own table. And as soon as you create a table, you'll get a GraphQL API that you can use to kind of query that data, to query that table, right? So we do that mapping between the API and the database automatically. And then Hasura also gives you the ability to kind of create these permission rules so that access to the database is not direct. So that you have role-based access, and you can control what columns and what rows and what objects end users actually have access to. We also automatically generate subscriptions and live queries on the database, which is irritating engineering problem to solve. And that's fairly performant and scalable. So you should be able to kind of build out real-time applications that subscribe to changes that are happening directly in the database. And that's what the project does. So please do check it out. Super young open source project. The engineering behind this has been in the works for a while, but we launched the project just about 4 or 5 months ago. So try it out, give it a spin. Please do join our Discord. Feel free to reach out to me, give me some feedback. Anything and everything you say will be super useful. So that's it on my talk. I have a small announcement to make. Along with a few other companies here in India, we're hosting GraphQL Asia. So if you or your colleagues are interested in doing a CFP, first-time speakers are welcome. Please do come by and chat about GraphQL. I don't know if it's feasible for you to attend GraphQL Asia because it's literally the other side of the planet. So you can kind of drill a hole through the earth and maybe come out on the other end. But if you do happen to be in India or in Bangalore and you want to make a trip out of this, you feel free to attend as well. But otherwise, do help me spread the word talking about GraphQL Asia. That's it from my side. If you have any questions, I can take them.
So, turn the camera around again. So thank you very much. That was an incredible talk. I really appreciate it. I learned so much about that. So whenever I need a data, some query on the server, I mean, GraphQL is the only way to do it, really. I mean, that's what I just learned about it. And if it's open source, yeah, please. I mean, what else? So thank you so much. If you have questions, please go and ask our presenter.
Yes, please.
Hi, thanks for your talk. It was really nice and very explanative. Since I see that your open source project is built on GraphQL and Postgres, so like you obviously had to do the database plumbing and everything, right?
Right.
Maybe I'm not getting the entirety of this, but my concern is that this is a language that only tracks on the API level. As you said, it has nothing to do with the database, right?
No.
So if I'm giving it fields or say pagination commands and options and such, right? It is not actually going to the database. So the database is actually giving it the entirety of the payload, and then on the GraphQL interface level, this is getting started.
Yeah, I see what you mean.
So how is there a way? Yeah.
Yeah. So I think the question is that if I have so if you're writing a GraphQL API server and if you're writing your own GraphQL API server, when you get a GraphQL query, you decide how to query and how to make that underlying request to the database. In our open source project, we're mapping that automatically to Postgres. And so when we're actually making those GraphQL queries, how are we processing it and how are we talking to the database, right? What we do actually is so we auto-generate the GraphQL API so that you don't have to build your own GraphQL API. And so we auto-generate the pagination, the sorting, the filter expressions, the nested filter expressions, right? So we auto-generate all of that. And let me kind of maybe I can just do a big screen share, which is the fastest way to explain how we do it. And this is very specific to our implementation, right? So it comes with a set of pros and cons. So let's say, for example, we query to-dos and the text of a to-do and a particular user and the name, right? And I made this query. What we're doing underneath it, so one, we auto-generate these kind of limit and offset things so that you have pagination. So you can say limit 1, offset 1, order by whatever you want to order it by. So you can order it by ID with ascending, right? You can do stuff like that. You can also say, I only want to fetch the to-dos where the user of the to-do has a name that starts with on, right? Just because you're being particularly specific about what you want, right? So we auto-generate like these different filter options for you to be able to make kind of whatever request you want to make, right? So that's what the API is. Now, what's happening underneath it is that whenever we're actually looking at this API call, And this is very peculiar to our implementation, which is the reason why it's super fast, is that we're actually a compiler. So our API server is actually a compiler. What it does is it looks at this GraphQL query, and this actually has a language. Because this has a language, what we do is we convert that to one single SQL query. And we convert that to one single SQL query where we're fetching exactly the information that we want. So you can see that the select statement actually fetches ID and text, just ID and text. And I can remove, let's say, the text from here, and you'll see that the generated SQL is, not fetching the text. It's just fetching ID and user. So we actually we compile that into a precise SQL query, and then we use that single SQL query to fetch all of the data in one shot. And of course, if there are permission rules, so for example, if you're selecting to rows that only you want, we'll inject the clause on the SQL query to add a where ID equal to current session ID. Right? So we inject those. When we create the SQL statement, we'll create the SQL statement by adding the right expressions to the AST, as it is called when we're dealing with like transpiling or compiling languages. But that's how we do it. That's not necessarily how you have a GraphQL backend. Like if you're implementing a GraphQL backend that's wrapping over REST services or that's talking to a database, you might actually end up making multiple requests to the database, or you might make a request to the database to fetch all of the data and then filter it out on the GraphQL server yourself to provide the interface to the client. But the client will never do any filtering on the client side. Everything will happen on the server side, and how efficient you choose to be on the server side is kind of up to your implementation. Does that make sense?
Yeah, actually, that makes a lot of sense. And your transpiling thing was pretty neat, I must say.
Yep, it's been a lot of engineering over a lot of months. So,
thank you.
Thank you. Yeah, please go ahead.
Did you write the compiler yourself, or is it you have like a whole team? Yeah.
No. I have a team. I wish I could say. I wrote the first version on top of a Mongo database, and then one of the earliest members in my team came along and said, "What is this Mongo thing? Replace with Postgres." Then we started replacing, and then we kind of rewrote the whole thing in Postgres. The backend is actually written in Haskell.
You run Haskell. Okay.
Yeah, which is ideal for writing programs. For writing compilers.
Yeah.
And for paying.
I
Okay. Not C++.
No, not C++. As fast as C++ maybe, but much easier to write than C++. Cool. All right, that's it, folks. Then I shall go begin my day because I'm 12 hours ahead of you.
Yes.
Thank you.
Thank you.
Yeah, thank you again. Very good. Very good. Appreciate all the talk and thank you for coming. We do have, the video is live on YouTube. So if you watch it or so, you can comment, you can add more questions. I will, get these questions published so these guys can help you, get your own stuff going. All right. Thank you again.
So and so cool, so real. You realize this is very Can you fill this in?
Yeah.
Like 4 people on my team.